To get the first 2 marks for this question, you need to say that the string is inextensible. So B moves up to the same distance that A moves down. And so the acceleration of B is a quarter g meters per second squares downwards. The first thing we need to do for part B is to draw separate force diagrams for both of our particles A and B. And now from these we can apply N to L to this object. So by N to L, the direction is up because that's the direction it's accelerating in, and it's on particle A. Okay, so we've got the resultant force in the upwards direction is T minus mg, that's equal to a quarter g, multiplied by the mass, which is m. Okay, and then we can do the same thing for the other particles, so by N to L downwards on B, and we've got it the other way around because the acceleration's in the other direction, so k mg minus t equals a quarter g, and then km is the mass. So again, let's call this one equation 1 and this one equation 2, and this time we are going to add them together. So adding gives the t's, these two will cancel, so on this side we'll get kmg minus mg equals a quarter gm plus a quarter gkm. So we can divide through by g, and we can divide through by m, and so we've got k minus 1 equals a quarter plus a quarter k. Okay, so all the k's on one side, so we've got k minus a quarter k on this side, and then add the 1 to both sides, so then we've got 5 over 4 on the other side, so we've got 3 quarters, k equals 5 quarters, so therefore 3k equals 5, so k equals 5 over 3. Okay, last bit is the SUVAT, so SUVAT. We know that S is 0.5 because it's 0.5 meters above the ground. We know that U is 0 because they're released from rest. V we don't care about. A we know is a quarter g. And T, V is the thing we're looking at. Yeah, so that's the one we don't care about. Right, so with these we're going to use V squared equals U squared plus 2AS. So V squared is going to be 0 squared plus 2 times a quarter g times half. And so we get that that is 2.45, and that means that V is the square root of 2.45, which is 1.565 which is 1.57 meters per second, 236 figs.